Lenodite forms as a result of a 70 million year old natural, chemical and biological humification process through reformation of animal and plant residues in special temperature, humidity and pressure conditions. Compared to other organic products, lenodite gains its edge with high cation exchange capacity and high percentages of humic and fulvic acids. The difference between lenodite and other sources of humic acids lies in its extremely bioactive molecular structure. With higher active carboxyl groups, lenodite provides essential nutrients, vitamins, and trace elements to plants and soil. In comparison, peat forms in only 2,000 years, but lenodite forms in 70 million years. Peat continues its mineralization process in soil, but lenodite directly increases soil organic matter without any further decomposition process. Soil microorganisms use organic matter nitrogen content. If nitrogen output from soil organic material decomposition is insufficient, then microorganisms uses readily available soil nitrogen for their needs, and this process ends up with nitrogen deficiency for plants. Due to continuous organic matter decomposition, other organic matter applications like peat, animal manure, and composts can cause nitrogen deficiency in plants. In terms of humic fulvic acids content and bioactivity, 1 liter of animal fertilizer. The benefits of humic and fulvic acids can be grouped into 5 main headings as physical, chemical, biological, ecological, and economic. Physical benefits. Humic acids modify the physical structure of the soil. They improve the structure of soil. They prevent high water and nutrient losses in light and sandy soils. Simultaneously converts them into fruitful soils by way of decomposition. In heavy and compact soils, aeration of soil and water retention capacity improves by humic acids applications. Helps the soil to loosen and creates crumbles that increase aeration of soil as well as soil workability. Increases water holding capacity of soil and improves drought resistance. Darkens the color of the soil and helps absorption of the sun energy. Chemical benefits. Humic acids chemically change the fixation properties of the soil. Neutralizes both acidic and alkaline soils. Regulates the pH value of soils. Increases buffering properties of soil. Improves and optimizes the uptake of nutrients and water holding capacity. Acts as a natural chelator for metal ions under alkaline conditions and promotes their uptake by the roots. With its rich organic and mineral substances, stimulates plant growth. Retains water-soluble inorganic fertilizers in the root zones and reduces their leaching. Possesses extremely high cation exchange capacities. Enhances the uptake of nitrogen by plants. Reduces the reaction of phosphorus with calcium, iron, magnesium, and aluminium, and liberates it into a form that is available and beneficial to plants. By that, it increases the effectiveness of the mineral fertilizers. Liberates carbon dioxide from soil calcium carbonate and enables it for use of photosynthesis. Helps to eliminate chlorosis due to iron deficiency in plants. Reduces the availability of toxic substances in soils. Biological benefits. Humic acids biologically stimulate plants and activities of microorganisms. Stimulates plant enzymes and increases their production. Acts as an organic catalyst in many biological processes. Stimulates growth and proliferation of desirable microorganisms in soil. Enhances plants' natural resistance against diseases and pesticides. increases root respiration and root formation, promotes the development of chlorophyll, sugars, and amino acids in plants and aids in photosynthesis, stimulates root growth, especially vertically, and enables better nutrient uptake, increases vitamin and mineral content of plants, thickens the cell walls in fruits and prolongs their storage and shelf time, increases germination and viability of seeds, stimulates plant growth, higher biomass production, by accelerating cell division, and increases development rate in root systems, thus increasing dry matter content in plants, increases the quality of yields, improves their physical appearances and nutritional values. In heavy clay soils, humic acids form clay-humic acid colloids and improve soil cation exchange capacity, CEC, and they hold macro and microelements in plant-available forms. Humic acids create calcium clay bridges in soil. With that, they increase soil permeability and nutrient holding capacity. By just using fertilizers, we cannot reach maximum crop yields. For maximum yields, we need organic matter humic acid, high cation exchange capacity, and biological activity. Humic acid effects on sandy light soils. In low humus sandy light soils, humic acids increase soil's nutrient and water holding capacity by coating sand particles. They hold water and nutrition in plant-available forms at root zone and give them to plants as they are needed. Humic acid effects on heavy clay soils. Humic acid physically loosens heavy, compact soils and improves penetration of nutrients, plant roots, and water into the soil. What is soil pH? Soil pH affects many chemical and biological reactions. Humic acid effects on acidic soils. By high buffering capacity, humic acids neutralize soil pHs and provide favorable conditions for agriculture. Humic acid decreases acidity-induced root stress. They precipitate with harmful heavy metals such as aluminium in the soil and prevent heavy metal toxicity in plants. Humic acid effect on alkaline soils. A high soil pH diminishes absorption of many essential nutrients and trace elements. By buffering pHs to desirable levels for plant absorption, humic acids increases nutrition and trace element transfer to plants. Humic acid also dissolves interlocked soil nutrients and transforms them into plant-available forms, such as calcium phosphate. Soil pH can be considered an important parameter for plant nutrition. In high acidity, absorption of nutrients such as nitrogen, phosphorus, potassium, sulfur, calcium diminishes. On the contrary, in high alkaline conditions, absorption of iron, manganese, boron, copper, and zinc decreases. Humic acid buffers soil pH to 5.5 to 7.5 levels, which is ideal for plant development and nutrient absorption. Thus, acting as a natural chelator, they help plant roots to absorb nutrients more efficiently, create long-term positive effects on soil quality and productivity. On the other end, conventional chemical fertilizers only show short-term effects without any plus benefits on soil structure and productivity. Under soil. Humic acid effects on eroded soils. On eroded soils, humic acids accumulate organic matter. By increased root structure and clay humus complexes help preventing erosion. Humic acids show various ecological benefits. Humic acid ecological benefits. The ecological benefits of humic acids are diverse and present profitable and effective solutions for environmental problems and the preservation of the environment. First of all, Soils with a high content of humic acids are a guarantee for low nitrate leaching and for optimum nutrient efficiency. A well-developed root system, which is achieved by a high content of humic acids, prevents that nitrate and pesticides mix in with groundwater. Furthermore, a low content of nitrate is an indicator and a prerequisite for appropriate organic agriculture. It happens very often that growers use fertilizers more than plants can take up. This leads to nitrate concentration in soil, which is later to be found in groundwater. A purification plant, which should sink contaminated water under a value of 5 mg NO3N per liter in complicated flows, means very high material costs at the same time. Instead of curing the symptoms, water contamination only, the root causes, nitrate leaching, should be fought against. Secondly, humic acids reduce the oversalination problem in the application of water-soluble mineral fertilizers. Humic acids are able to decrease high salt contents in soils and thus the resulting toxicities. Especially the NH4 toxicity of fertilizers containing ammonia is reduced, which is of great importance for young plants particularly. Generally, humic acids reduce root burning, which comes about through excessive salt concentrations in soils after fertilization. In case of permanent high levels of salt in soils, these are reduced. Furthermore, when humic acids are mixed with liquid fertilizers, the undesirable smell is diminished. Thirdly, humic acids are an effective means to fight against soil erosion. This is achieved both by increasing the ability of soil colloids to combine and by enhancing root system and plant development. Humic acid and its benefits have been certified by many international organic agriculture institutions. Economic benefits of humic acids. Humic acids chelate nutrient compounds, especially iron, in the soil to a form suitable for plant utilization. Thus, the nutrient supply of plants is optimized. High increases up to 70% in yield, accompanied by a reduction of up to 30% in the use of fertilizers and pesticides, as well as better and healthier growth of green grass, ornamentals, agricultural crops and woods, can be attained with the regular application of first-quality humic acids. Furthermore, water holding capacity of soils is increased considerably, which means that use of water can be reduced substantially. The best economic results can be obtained in light and sandy soils poor in humus, as well as on recultivation fields. The diverse positive impacts of humic acids are to be observed particularly in such soils. This is true for almost all soils in dry and warm regions. As a result of the high mineralization rate of organic substances, providing these soils with stable humic acids is indispensable for the maintenance and improvement of soil fertility.